Alright, so in this session we're going to take a look at microphones. Bit of session structure for you, so we're going to start off with what is a microphone. We're going to move on to different microphone technologies, look at understanding polar patterns, then we're going to take a bit of a discussion about the proximity effect, and we're then going to round that off with a bit of a demonstration of a few different microphone types and microphone polar patterns. So first of all, just to kind of get the basics out of the way, what is a microphone fundamentally? So a microphone is a transducer that takes vibrations from the air, converts them into an electrical signal, something that we can use in the DAW. So our singer that you can see in the diagram here is singing into this microphone, which is a Neumann U87, for those of you who were wondering what microphone in particular that is. And then that electrical signal goes into our microphone preamp and eventually makes its way to our converters, and then is something that we can use to produce music with. So if a microphone is a transducer, then surely like the opposite of a microphone will be a speaker, because that takes electrical signal and just pushes it the other way and turns that into acoustic energy. So a speaker is also a transducer, in that it's just acting the other way around, where we're taking that electrical signal and this time making it acoustic energy. In that sense, a speaker is actually pretty similar to like a dynamic style microphone, something that we're going to look at in a second. And you can use speakers as microphones, and that's something that we'll be exploring in kind of further sessions, and can be a really interesting thing to get you some kind of less predictable results. So, a little bit of history. I've gone with the dry white slide for this one. So, microphone was originally invented in 1876 by David Edward Hughes. This kind of considered the first microphone where you're working with what we refer to as like a carbon button. So sound waves go in, you have a load of carbon atoms against the diaphragm of the microphone. The diaphragm of the microphone, by the way, is essentially the microphone's eardrum. So where you look into a microphone, if you have like a large diaphragm condenser microphone such as a U87, you can see there's like a kind of small circle shape there. That's the diaphragm of the microphone that is effectively acting as its eardrum. That would vibrate carbon granules which react against a fixed electrode, and that kind of combination of that stuff turns into your electrical signal that you can then use. So that's your first kind of real instance of a microphone. We're thinking now of, the old dialed house phones that everyone used to have. A lot of those were carbon based. However, we don't really use too much carbon-based stuff these days. We've moved on to kind of three main types of microphone technology. The first of which being a dynamic microphone. So this example here is a Shure SM58. A few kind of characteristics of a dynamic microphone. So it doesn't need any additional voltage or any like really advanced technology to get it to work. You can generally just plug this into whatever your interface or desk or preamp is, and they'll kind of they work off the bat. They're extremely durable and less sensitive. Where I say less sensitive, it's really important to understand what I mean by that, and that is that they're less sensitive in terms of durability. So if you kind of drop one of these, the Shure SM58, odds are it'll be fine. Hence why they're used in live performance all the time for usually vocals. You have the brother to this, the SM57, which is like the instrument-based version of this with a slightly tweaked frequency response and a different grill. That is also, again, less sensitive in terms of durability, so they can be knocked about, dropped, whatever, on a stage or in a studio situation, and it's still going to work. They can take quite a bit before they start panicking. And it's also less sensitive in terms of audio. So a kind of downside of a dynamic microphone is that it needs something pretty loud before it can kind of get going. So anything like if I'm doing here, like just a spoken voice thing, you might need to have your gain considerably high on a dynamic microphone to be able to get that to to do its thing and react properly, and where you have the gain really high on your preamp or interface, whatever it is. If you gain super high on that, odds are you're introducing a little bit of noise, a little bit of hiss. So dynamic microphones, generally, we can kind of stick to something that's got a bit of volume to it. So, a lead vocal, but not necessarily like whispered stuff, but guitar amps, drums, brass, whatever, anything that's got a bit of volume to it that can get this dynamic microphone moving, then it's a perfectly good application for it. So apologies if you can hear my dogs. So essentially, sound waves from the microphone, from the air, hit the diaphragm of the microphone, which is concealed in this basket here. And then dynamic microphones work by, they have a static magnet and a coil of wire around those, and the reaction between your kind of diaphragm with those moving coils and your magnet generates an electrical signal, which they can then use to record. So that's a quick kind of go over of your dynamic microphone. Let's look at the next type of microphone, the condenser microphone. This example of a microphone is your AKG C414. As far as microphones go, that is an absolute jack of all trades kind of microphone. It's great at pretty much whatever you want to put it against, but it's not the best at anything, I'd say. So it's an awesome microphone if you just kind of getting your way into recording stuff, and maybe you're not 100% with what technique to use on a trombone or how to record a cello or whatever. It's something a little bit kind of out of left field. A 414 is a really good kind of fallback, this will definitely work kind of thing, just because of the flexibility of them, and they kind of have a bit of a more neutral kind of tonality. So with condenser microphones, we're generally talking that they are more sensitive than dynamic microphones, both in terms of durability and in terms of receiving audio signals. So condenser microphones, you've got to be a little more careful with how you're handling them, just because of the technology and how that stuff works. So if you were to drop a condenser microphone, then chances are it'll still be okay, but try not to. So they're a little more sensitive in terms of what they can handle. You won't see many of these in kind of live situations, because again, if they're getting kind of kicked around a stage, then they can't really handle that stuff too well. So they're not as durable as a dynamic microphone might be. However, they are more sensitive, again, in terms of pickup pattern. So I'm speaking into a condenser microphone now. As you can hear, I'm able to speak at a relatively common level, and I've got no problems with like microphone hiss or anything, because I don't have to turn the gain of my preamp up particularly high to be able to capture a source at this level. So condenser microphones are really, really popular for capturing vocals, because we can go right from a whisper to a belt to whatever, and it can handle all that dynamic range. In terms of that as well, where we were looking at a dynamic microphone and I stated that this was less sensitive, we also have to think that because it takes a little bit more acoustic signal to kind of get going, it can also handle much, much louder sources than a condenser could. So say, for example, to kind of draw a line there, you could put one of these, a Shure SM58, on top of a snare drum in a heavy metal band where the drummer is absolutely hammering the thing, and you'd have no problems in terms of SPL. If anything, that's a bit of a comfort zone for a dynamic microphone to live in. Whereas something like this, the AKG C414, on a metal snare drum where it's been absolutely hammered all the way through the track, you may be going to run into some problems there. What you'll typically have with SPL issues is it's generally just the way the wave moves, and it has so much energy behind it, it causes the diaphragm to move too quickly, and so it can't kind of capture the signal as it should. So like if I blow into this microphone that I'm speaking into, you'll hear an SPL issue. Did you hear that then? That the audio kind of, you just get this kind of thing. If I blow past the microphone, you hear there that the closer I'm getting to that diaphragm, the more of that rumble and kind of SPL issues you're going to get. So I'll do that again. I'll start by blowing over the microphone, and then I'll slowly move towards it. So those are the kind of problems that you could come into. If you're recording like a jazz snare drum where it's, maybe brushes, it's been played a little softer, then a condenser microphone's going to have no problems whatsoever. Small diaphragm condensers, so this is a large diaphragm condenser. The smaller models of these that are more like pencil mics, they tend to be actually pretty good at SPL, so they probably could handle a metal snare drum. It's just one of those, depends on your player, depends how loud the drum is, all that kind of stuff. So they can handle pretty loud signals. You could easily put a condenser microphone above a drum kit or in a room with a drum kit and have no problem whatsoever, regardless of the genre. So condenser microphones do require additional voltage to function. They need 48 volts, which is also known as phantom power, which is direct current. On your preamps that you may be using, or an interface you've got at home, or whatever it is you're working on there, you'll have a little switch that says 48V on it. That's referring to the 48 volts of phantom power that's required by condenser microphones to be able to function. So if you don't have that available, most interfaces will have that available. If you don't have that available, then you wouldn't be able to use this kind of microphone. Again, 99.999% of preamps will have that option because manufacturers recognize that we have to be able to use kind of all the different types of microphones. Interestingly, a lot of preamps, although they say 48 volts phantom power, a lot of them don't fully give that power. A lot of them may sit around, the kind of 44 or as low as kind of 20, 30 volts, where your microphone will still be able to function. It just might not be giving you quite the same kind of frequency response and behavior that it would at a full 48 volts. Hence why you also, kind of regardless of the topology of different preamps and stuff, even one preamp to another will give different phantom power and will allow that microphone to behave differently. So the phantom power you get from a desk may be slightly different to the phantom power you get from a small interface. They will make minimal difference, but it is one of those things just to kind of bear in mind. In terms of how a condenser microphone works, again, you have sound pressure waves. We have the diaphragm of the mic here, which is then fixed to a pair of bias plates, and it's your kind of phantom power that allows the electrical signal to get those plates moving in reaction to the diaphragm, and then your signal goes out. I'm not going to bog too much down in the kind of technical details of it, more the kind of practicality of using the different microphones. So here's just a quick diagram of a capsule for a microphone that we were talking about earlier. So where we looked at the example of the U87, where it has that really small circle there being the diaphragm, the eardrum of the microphone, if you will. The 414 has it there, and here's kind of an exposed front plate, which is your diaphragm. We refer to like the whole unit, you'll hear referred to as the capsule, and the back plate for that is just resting just behind the diaphragm there. Cool, so bit of a recap on what phantom power is. That's your 48 volts of direct current used to polarize the condenser microphone, i.e. get it working. Phantom power can also power passive DI boxes, which is something that we're going to look at in the recording with high amplitude session this year. Again, it's only for condenser microphones. Ribbon microphones, which is the next type of microphone we're going to look at, can be damaged by that additional voltage, so it's reckless to use that as maybe like an always on thing. So dynamic microphones, if you're running phantom power through those, odds are they're going to be fine. You're not really going to do any real damage to a dynamic microphone by having 48 volts running through it. It is excess electricity that you're pushing into that thing. So if you are like me and you're not necessarily an electrician and the idea of pushing extra voltage around where it doesn't need to be scares you a bit, then maybe avoid doing that. So what I'd say as a kind of general rule for using phantom power is always make sure that it is not enabled before connecting your condenser microphone, and make sure it's always disabled before disconnecting your microphone. So plug your mic in, then phantom power, then when you're finished, phantom power off, then unplug your microphone. The idea with that is if you're kind of hot plugging, which is where you have phantom power on and then you plug the microphone in, the way your XLR cable is designed is that it wants to make all three of those connections at once. If anyone's looked at the inside of an XLR cable, you have 3 pins, hot, neutral, and ground. So if those pins aren't making contact all at the same time where that phantom power is pushed in, then you're looking at your phantom power maybe going down kind of the cable incorrectly, and you can get, power fires back into the unit or just kind of goes wherever it wants, and it's just a little dangerous in terms of kind of doing that. You'll get, you'll run into maybe some older engineers that'll be like, oh, I never turn it off, I just always leave it on, I don't have any ribbon microphones, so I don't see the point. You kind of, every time you unplug that, you're running the risk of damaging your condenser mic, so always make sure phantom power's off, particularly where you're using microphones that aren't your own, such as in the BIM studios. Ribbon microphones. So a few things about ribbon microphones. Generally have a little bit less top end, so a little bit less in the kind of higher frequency range. They tend to have a bit of a roll off there. Largely due to the technology of it, which is that we're working with magnets here, similar to a dynamic microphone. However, this is in a U shape with a small kind of corrugated ribbon of metal in between there, which is then connected to a transformer, which generates your electrical signal that you can then record. So essentially with a ribbon microphone, you're after the interaction between the magnet and a kind of floating suspended ribbon in between there. Now, the thickness of that ribbon will determine how much kind of high end you have, but some of these ribbons are kind of in the area of the same thickness as like a human hair. So you can imagine with that if you put too much kind of air pressure behind that, or you drop it or anything like that, that ribbon can fairly easily break, at which point you then have a useless microphone. So ribbon microphones are the most sensitive in terms of durability, so like handling and what you can kind of put them against. So this is the kind of thing that I would never dare put a ribbon microphone as a spot mic on a snare drum in a metal context. It's a very brave move to do that, and odds are you're not going to get much use out of that ribbon if you're subjecting it to that much air pressure all the time. Whereas maybe, an overhead on a drum kit or a room mic for a drum kit, regardless of genre, it's cool. So it's not too far off the kind of durability of a condenser microphone, but they are more sensitive to those really kind of high pressure waves. So you can get away with a ribbon microphone on a guitar amp, for example, as long as it's not absolutely deafeningly loud. Things like a really absolutely hammered snare drum, maybe not. So they can't handle as high SPL levels as dynamic or condenser microphones. They're the most sensitive to damage, and they generally have less top end, which all kind of sounds like disadvantages, but ribbon microphones are kind of hailed for having like the most, let's say, natural or transparent kind of tonality to it, and it sounds quite a lot like how it did in the room kind of thing. However, with that, ribbon microphones are also kind of they're an older technology, and so we associate them with a lot of like the kind of early Beatles stuff, and with that they have a very vintagey tonality to them dependent on manufacturer. So a microphone like this, for example, which is the Coles 4038, originally the STC 4038, they were used constantly in the Abbey Road stuff. They bought a load off kind of ex-BBC stuff. It's all UK made, so it was really easy for Abbey Road to get a hold of those. So Abbey Road is flush with ribbon microphones, really, and it has been for a long time. And you can hear them on a lot of those older recordings, so it's something that's become really desirable. Again, difficult to kind of manufacture and maintain because of how sensitive they are, but they do have a certain kind of vintage to them. Then again, you have companies such as Royer or AEA that are now making more kind of, let's say, high fidelity, less vintagey ribbon microphones that have a little bit more top end. It's up to you guys to decide your own kind of personal preference on what brands you like and what kind of different microphone types and whatever you want to use. For my own personal taste, I feel like if I'm using a ribbon microphone, then I'm using a ribbon microphone. I don't necessarily want it to have that super high fidelity sound like what you're hearing off this condenser microphone now. I like it being a bit darker. That's a huge advantage where you're doing stuff like recording drums. If you have a set of these trying to capture cymbals, your cymbals don't sound as harsh because they've been kind of rolled off by the natural darkness of the microphone, and so your drums can shine a bit more and it tames your cymbals, whereas a condenser might be a little bright depending on the drummer, depending on the cymbals, brand, etc. So it's just a personal preference thing. For me, if I'm using a ribbon microphone, I like it to sound darker, a bit more colourful, a little more tonal. So it's just kind of a brand to brand personal preference thing. Cool. So we've looked at your three kind of main microphone types there. We've looked at dynamic, condenser, and ribbon microphones. And I wanted to look at different polar patterns. So the polar pattern is a way that manufacturers can illustrate how a microphone responds to sounds incoming from different directions. So each polar diagram is frequency specific. So if you're looking at a polar diagram like this, that polar pattern, this black line is probably more in line with the around 1000 hertz area, and the response of that will alter slightly depending what frequencies you're looking at and the type of microphone, etc. So these provide you a really essential bit of information on how that microphone can be used in different situations. So say, for example, at the minute, I'm speaking into a cardioid microphone. I'm speaking into the front of this microphone and you should be able to hear me fairly clearly. Whereas if I move and start speaking around the back of the microphone, do you hear how that got a little bit roomier and a little bit less distinct? And now if I move back to the front of the microphone, I get more low end, I'm a bit more present, there's less room in the signal. That tells me that the microphone essentially is rejecting whatever comes in at the back and is picking up accurately what comes in at the front of the microphone. Again, if I move more towards the back, you'll hear that I'm kind of being rejected and I get a little quieter in this microphone, start sounding a little bit odd. And as I move towards the front, I get that kind of clear capture again. So that's a cardioid pickup pattern where we're looking at kind of just the front and a bit of the sides of the microphone. It's called cardioid. If you think of cardioid, cardio, cardiovascular stuff, that all relates to your heart, which is cardiac. So it's essentially an upside down heart shape that's comes from that. Omnidirectional refers to where the microphone picks up evenly from all angles. Now I've used this polar pattern here because you can see by this legend that around 200 hertz it's still omnidirectional. It still gets picked up all around the microphone. However, towards the back we start getting a little bit less low end. So it's still going omnidirectional. In this case, again, that 1 kilohertz area is kind of perfectly even according to this diagram, whereas as we go higher up the frequency spectrum we start losing a bit, and as we go lower down the frequency spectrum you also lose a bit around the back. So cardioid can be super useful in situations such as this, like maybe voiceover or any vocal recording, where maybe you're working on, let's stick with vocal recording actually. So let's say we're doing this, let's say I'm recording a lead vocal here and I'm using a cardioid microphone. Now your lead vocal, 9 times out of 10, you're going to want absolutely smack in front of the mix, sounding really close, really intimate, kind of on top of everything else almost. But backing vocals, I mean, the clue's in the name, innit? Backing vocals. So they should be backing up what the lead vocal does. Omnidirectional is great for that because it has a little bit of that natural room sound to it, which keeps it a little bit further back than a cardioid microphone would be. So kind of right off the bat, as an engineer, you can start making these decisions as, okay, I want my lead vocal at the front, so I'm going to use a cardioid pickup pattern for that. And I want my backing vocals to be a little bit further back, a little more ambient sounding to allow that lead vocal to sit at the front. So I might use omnidirectional for my backing vocals. Whereas if you'd kind of tracked everything in cardioid, you might be fighting yourself a bit there, because if it's a difficult thing to explain this, I guess. If everything is at the front, then nothing stands out, does it? If everything is kind of right in your face all the time, then nothing is in your face because you don't have that contrast. In the same way that you can't have light without a dark, you can't have anything forward in your mix without having anything a little bit further back in your mix. It's that contrast that's going to give those clear relationships. Hypercardioid. So this is similar to cardioid, but we have a little bit of a different rejection here. So on cardioid, we're rejecting primarily from the back. Hypercardioid, it's a little more off to an angle, off to the sides. Your front pickup is more accentuated, but the two null points around here and here create some nice off-axis rejection. This is, super useful for, let's say, recording a snare drum where you might have a really loud set of hi-hats off to the side of that. Depends where you can get your mic. If you can get your microphone underneath those hi-hats and reject them from the back, maybe cardioid is a great idea. If those hi-hats are really low down and you can't fit a microphone in, then maybe we could use something hypercardioid and just have it slightly off to an angle. So the hi-hat is here, your snare is here, and then you're rejecting as much of that hi-hat as possible. It's also worth noting that we do have this extra bit of pickup at the back with a hypercardioid pattern. However, do also bear in mind that the front pickup is much more accentuated. So this extra little bit you get at the back may not necessarily be an issue, just depends how you're trying to use it. Finally, going on to bidirectional or figure of 8. This is the natural polar pattern of any ribbon microphone. You can now get ribbon microphones that are not figure 8. However, this is typically 99% of your ribbon microphones are going to be in figure 8. Figure 8 is where we're picking up sound from the front and back of the microphone, but as you can see, we're rejecting either side there. That can be really, really useful in situations like maybe if you're doing an interview with someone, so you only have one microphone and you want your voice and their voice to be equally prominent and you want to reject anything else that's going on in the room. They can be really useful for, let's say, if we're doing acoustic guitar and a vocal at the same time. If you have your acoustic guitar in the pickup area and you can get your vocalist singing in the null area of that, then you can reject the vocals and pick up the guitar and have a lot less bleed from that, or spill, whatever you want to call it. Few characteristics of figure 8. I think in my kind of experience, this rejection point on a figure 8 is the most obvious. It seems to be that figure 8s are particularly good at rejecting the stuff that's not meant to be there. You also will naturally get a nice bit of ambience wherever you use figure 8 stuff, as well as some nice close placement. So it tends to have a fairly natural sound to it, hence why it pairs nicely with the idea of using a ribbon microphone. Cool, so there's another advantage of bidirectional or figure 8, which is mirrored in the frequency response of the Shure Beta 56, and I'm going to get to that now. So this is actually a kick drum microphone. So what we can see from this thick red line here is that this microphone past about, let's say, 5-6 kilohertz, maybe 7 or 8 kilohertz, starts rolling off. So it's not really, for a kick drum microphone, very good at picking up that 100-200 hertz area or anything lower. Now, anyone that's mixed a kick drum knows that that's a pretty important area for your kick drum. That's where all your low end is, that's where the thump is, that's the bit that's going to hit you in the chest. It's where all the bass is, and for a kick drum to not have that, it's going to come across really weak. But we do have these extra lines here where we have 51 millimeters and we have a bump there, 25 millimeters we have a bump there, and 3 millimeters we also have a significant bump there. So what that tells us is that microphones will tweak their frequency response dependent how close they are to the source. This is called proximity effect. So the closer a directional mic gets to its intended source, the low frequency range will increase in volume. So figure 8 microphones, such as ribbon microphones, are I don't want to say worst for this in terms of how much proximity effect they exhibit, but they have the most kind of proximity effect, your bidirectional stuff. Omnidirectional does not have any proximity effect. So let's kind of talk about where this might be useful. So this Shure Beta 56, having a naturally not that great low-end pickup response means that it's actually really, really useful in a kick drum, because we can get the microphone really inside that drum, out of the way, so no one's going to trip on it or anything like that. And with it being inside the drum, if you're getting this microphone right inside a kick drum, if it's inside that drum, it's a lot harder for it to pick up the sound of cymbals, snare drums, toms, room mics, guitar amps that are in the room, whatever else it may be, hi-hats, because they're all kind of blocked out by this big kick drum. So it allows us to have less bleed by getting the microphone inside the drum, and it allows us to still have that low end that we really need in a kick drum, and be able to get that with the kind of combination of very little bleed. So that's kind of ideal for like a spot mic. It might not necessarily be ideal if you wanted it a little further away though, so it's kind of horses for courses, depends what you want to do. So proximity effect can be a really useful thing there. But again, it's applications. So if you're working in omnidirectional, you're not going to have any proximity effect, which is actually really good for a vocal. So if I get really close to my microphone, and I'm going to have to put a pop filter up here so it doesn't freak out. If I get really close to my microphone, the low end in my voice seems a lot more impressive. Whereas if I go further away, my voice gets dead tinny and a bit weird. So the closer I get to the microphone, I'll get more bass response out of it. Where you're tracking a vocal, that can be a bit annoying, because you'll have some vocalists will typically tend to lean back on louder parts, so that really big impressive belt that you're going for at the end of a track where it's this huge note that really uplifts everything, and maybe there's a big breakdown there or a drop or whatever it is. If your vocalist is super far away from the microphone because they've kind of leant back a bit, then you lose all that bass response. A way around that is to ask your vocalist that where they move away from the microphone, if they do it to the side, as I'm doing now, you don't really lose too much low end, and you can still maybe take a breath or whatever they need to do. But again, omnidirectional doesn't exhibit that effect, so you could have a vocalist record a full track into an omnidirectional microphone and not have too many issues with the low end and have a really consistent vocal sound, but you'd have a bit more ambience in there. So again, it depends what you're going for. As Mr. Garth Brooks would say, every blessing is also a curse. Every curse is also a blessing. Everything has an upside, everything has a downside. It's up to you as an engineer to work around that and do what you can. So this happens due to the nature of the way directional mics work. So polar patterns work by the microphone being able to relieve pressure at certain points. And if it can't relieve that pressure, then it either becomes omnidirectional or we start getting proximity effect. So there's a couple of instances there where it may be useful or an issue, and I've kind of already explained that the most prone to proximity effect is actually figure 8. Cool, so now that we've kind of been through a bit of kind of technical spiel about all these microphones, we're going to have a bit of a demonstration. So what you're going to hear in this video is we're going to set up 3 of exactly the same microphone, which is going to be the Rode NT2A. We're going to set all 3 of those up in exactly the same position or as close as possible. And we're going to have our drummer, Dean Marshall, who also works at BIM Manchester, just play kind of a fairly standard beat for you. And in that section, what you're going to hear is I have one of those microphones set to omnidirectional, one of them is set to figure 8, one of them is set to cardioid, and we're going to jump between the 3 so that you can hear just how different those polar patterns are in terms of response as the drummer is playing. And then in another demonstration, we're also going to look at 3 different microphone types, all set to cardioid. So we're going to be looking at an SM57, we're going to be looking at a... actually, they're not all set to cardioid, so we're going to be looking at an SM57, which is in cardioid. We're going to be using the T-Bone RM700, which is a ribbon microphone, so that's naturally figure 8. And we're also going to be using the Rode NT2A, which is again in cardioid. So the idea of that second demonstration is that you get dynamic, ribbon, and condenser. So your first demonstration is going to be omnidirectional, figure 8, and cardioid, perhaps not necessarily in that order. And the second demonstration is going to be dynamic, condenser, and ribbon microphone. So let's take a look at that demonstration and see what you think. Make sure as well that you are listening on high quality monitoring. If you're just listening on laptop speakers or a phone, these kind of small differences are going to be very difficult to pick out. So just make sure you've got some quality monitoring going on.